So today we've got a box of radios in, and we've got a well-used York JCB863. I understand that it's had some kiss of death modification to squelch. We'll start by taking these 4 screws out, but I'm sure it'll be 8 screws. So hopefully we can modify it back. He's also sent a Binatone 5-star, and that's had the same modification. Oh, what on earth's all this? Oh, I thought it was a squelch modification. It's the blooming illegal channels modification. Oh, let's see if we can reverse it. You know how to turn a good quality set into a rubbish performing set is these bonkers modifications. I think it's just that they just want to be illegal, don't they? They don't want anything that works nicely. They just want it to be illegal. It's part of the fun. Right, have we got a bit of a power lead? Do you know what I'm going to do? I'm going to power it up with it as it is, and we'll see how well it works, because usually these modifications have killed the set. It's not the time that this takes to take out, it's what switches they've redeployed to something else. That wiring takes ages, and it all has to be... I end up having to take another set apart usually to find out what's been messed with. So that's the biggest bugbear. Right, have we got, as I said, a little power tail for these? The customer's has also sent in a Kernow KR200 and an Amstrad 901 early version with the funny connector you can't get. Let's see if we can get the prop of that clip to just go in the hole. We sent power leads in, but they're in a different room, you know the score. Oh, so we're on, and we're at channel 20, and forget the clipboard. I want the extension speaker that goes to the test instruments plugging in. We'll put the PA speaker in. I'll go and get a microphone. Now the customer has sent mics in, he sent power leads in, but I just like to do it on our standard one. So we're going to transmit. Let's put picture in picture on. And we'll go through it as presented. Okay. So we're on channel 20, and we'll show the frequency counter. 27305, folks. 27305. Well, it should be 27205 if it's channel 20 CPT, which is probably what they've aimed to do, but it isn't. It's channel 20 it's something else, isn't it? So what button do we have to press to make it work? Let's just see if it works on... Oh look, PA doesn't work. So perhaps if we put it in PA, it transmits on something different. Now if you put it into PA, it doesn't transmit at all. Okay. So we put it on channel 19, that should be 27185 if it's UK. If it, yeah, 065. It's let's go to channel 1. I'm just wasting my time, aren't I? 2760 something 27. So that you would think is channel 1 UK, but off frequency. Once when we press, that's in PA mode, and in non-PA mode it doesn't work. Channel 40, in normal mode it's 27185, which is channel 19 CPT, and if we go to non-PA mode, right, well the VCO won't lock, will it? So what we'll do is we'll test it on the channel it is working on, which is channel 1. Now this is a waste of my time because I've now got to reset everything for channel 1 just to prove. And I'll deliberately put it off frequency because the radio is off frequency. 076. Let's have a look at the sensitivity. Make sure the RF gain's up, because it wasn't. Okay, so we're getting our first figure. Let's put the cyanide meter up. And we have a very, very good 0.23 microvolts. So maybe they didn't untune the radio when they put it on the CPT set of channels as well, which meant, of course, it would be very, very lousy performance. What's that? 0.48. See what power it's doing. Make sure we're in high and not low. We are in high, and it doesn't transmit. Which is on the. There is no transmit. So that's going to be VCO. So where were we before? Do you remember? I think we were on channel 20 and it was some bizarre other channel, weren't we? So let's go back to channel 20. Let's find something it actually transmits on. I don't think it transmits on anything anymore. Let's put it on channel 9. Didn't transmit on there. I did see it transmitted about 100 milliwatts when I first came to it, which is why I was able to tell you what it was working. Anyway, it's not transmitting now. Okay. I just put 27305 in because I definitely saw that when it was transmitting. I'll put 27305 in on the signal generator. 27.3. And what this proves is they haven't killed the face like loot chip. Right, 27305. Yeah, so that's where we were. That's where we started off. So it doesn't transmit on there anymore, unless it's got a dicky power switch. Ah, that's it. So we are transmitting, and I'll go to that meter in a moment. Let's see what the sensitivity is on 27305, and it's still 0.21. So right across the channels they've added, it's still good sensitivity, which surprises me. Now on transmit, one of the few channels it does transmit on is this, and it is doing, we're on the low scale, so if we're in the 3 watt range, we are looking at, let's point with that to my massive fingers, if that was 3 watts, 1 watt, so 0.5, 0.1, so key up and you see it's there, so it's about 0.8 of a watt is where it's transmitting. So let's hope we can bring it up from 0.8 of a watt. Right, well, there's nothing for it. All this junk's got to come out. You can see where I'm getting at. They turn a really good legal UK set into a really rubbish illegal set. I don't know how many times I have to say that you can't add channels onto a UK set. The idea was you bought a separate set until legislation allowed for 80 channel sets under PR 2797. So I don't know what that capacitor does. Just going to the PA switch. This is where they've mashed up the printed circuit, and that's been linked with wire, which is actually nicely done. So I'll start by taking this off. The only way to get to this is to remove the channel selector. So votes on a postcard. I think, I'll tell you what, we'll take the chip out and put it back, because I think that's what they've done. Anyway, you don't want to watch me with a solder sucker, so I'll do this. Okay, so having got the LC7137 parted away from the other IC, we come to the problem that they've cut a pin off. So instead of charging the customer £16.99 for a replacement chip, we'll see whether we can solder a bit of wire on that. And then of course we'll see whether we can get it to go in the hole. I'll leave this lead long and chop it off when we've got it in the hole. Good. See whether we can thread the whole thing through. I will end up taking the channel selector switch off. So it's the 1, 2, 3, fourth one up that. 1, 2, 3, 4. I'm just hoping if I can thread it in the hole, the rest of the IC will be easy to locate. I've checked the pins aren't all splayed out. Oh, got them to all go in. So what's missing from there? Capacitor 2? No. Should be a resistor there. Ah, one end of it is there, and they've got, I can see the colours, it's probably the same resistor, they've just, I think it's the same resistor, they've just kind of shifted one end of it. I think we're going to take the resistor out. I think that's the right spacing. Yeah, that's gone straight in. So if I hold that with one finger, hopefully we can solder that back. Goes without saying I'll be cleaning this area of the board with isopropyl alcohol. So that's one of the things that they've obviously done. But of course, having disconnected whatever they've done on this switch, it's not going to just fix it, is it? Or is it? I don't know. I'm going to have to rewire the PA switch, and that's, as I said earlier, it's very costly in time. Sometimes they cut tracks, I can't see that. Okay, so we've got to do something else because it's not transmitting or receiving. So there's some link, some missing component which is key to its functionality. So I'll have a look through. Okay, so cleaning with isopropyl alcohol's brought it back working. So let's see what we've got on transmit. And the answer is we haven't. No change there. So let's see if we can do the VCO, or whether we've got something not quite right on transmit. So monitoring resistor 4 should have 4 volts in receive and 4 volts in transmit. On channel 40, what am I doing? Going to transmit. So the VCO's doing it, but the PA isn't. Just wiggle this round in circles. Could be on a false lock point, which I think it is. 3.9 and it's transmitting, and our receive is still around 4 volts. So it was on a false lock point, which is fair enough. Oh, before I disconnect it, the kind of checksum is to make sure it's around 1.72 volts-ish on receive, on transmit, on channel 1. So there we're 2.14, that's fine, and on transmit it's 2.18, so that proves we're correct. So hopefully, looking at that, we've got full-scale deflection of the meter. Probably going to do this minus the PA, and I'll spend tomorrow, because it takes about 90 minutes to do that, and I'd like to get this kind of on the air tested if we can get it to that kind of stage. The two jobs take as long as each other. So first of all, can we get it on frequency? Because if you remember, it was a bit low, but of course the modification may be part of that. So let's have a look. We'll go over to the there's all kinds of crud in the way, but you know, that's where the frequency counter would be. It's doing 4.5 watts, which isn't good news. Because they could have got it on what we call service mode. So it's been thrashed. It's 4.2 watts on there. 79204, it's actually high, which is good. So it was their modification causing the frequency to be wrong. 2779125 we're looking for. Excellent. So it was was it 80 milliwatts? No, it was 20 milliwatts, wasn't it? I'll put 80 milliwatts anyway. Remove illegal 80 channel modification. Good. I'm going to check one on 40. 60125 channel 40 should be 99125. Yeah. There we go. So we need to tune up the transmitter. I'd say it's doing 4.5 watts, which isn't, obviously it's above the legal limit, but I'm not so, it's not that I'm bothered about that. I'm sure the DTI are going to rush and take somebody to prison for that. But it usually means that they've got this maxed out, and it's not how it works. You know, it's like it's the you don't do that. The reason the radio can do slightly more is you can balance the power over the 40 channels, and as you can see, it was well balanced at 80 milliwatts as it was working before. So we'll start by trying to get this in the centre of the peak. You know what? It was in the centre of the peak. I don't think they've untuned this. They've kind of done half the modification and not retuned the radio. So that's all as it should be. So if we get the blue tool out of this kit, so it's maximum. I'm not showing you the right meter. So it's 4.2 watts as the set's warmed up, the power of course has dropped. By the way, it's 1.272 amps at the moment. And it's 4.4 watts. I'm not trying the other channels. We could try low power though before I undo it. Low power is doing 510 milliwatts. So not stupidly wrong. So maximum on the yellow one. So that was at maximum. Maximum on the white one. That was at maximum. Maximum on the green one. And that was at maximum. This is what they've done. They've maxed it out. It's not how it's done. It's not going to get you better range. It's going to get you a knackered PA and lots of harmonics. So what we now need to do is to drop clockwise on the for this one for 4.4, but we're already at 4.4. So I'm going to have to just do it so it's just a difference. So I've actually got 4.2. Normally they'll do a little bit more power than this, but it's been thrashed, so you don't know what's what's happened. And that is spot on the 4. Now the manual says 3.8 watts, but I always make sure we're at the maximum legal limit, which is 4. So let's see if it's anywhere near, because I want it to be within 0.1 on channel 14, channel 1. Well, we're spot on channel 40 with 4 watts, and on channel 1 with 4.0 something. So let's put 4.02, 4 watts, and 4 watts. So that's nicely balanced. So despite it having been thrashed, it has balanced up nicely. So we'll go back to channel 20. We'll look at our current consumption. It's now 1.227. 1.2, we'll put 2.3 by carrying that over. So it has dropped marginally by not being thrashed. And our low power is probably all over the place now. The low power is now 580 milliwatts. We'll just drop that to the 400 milliwatts it's supposed to be. Preset's dirty. Put some service on that, unless of course the preset's knackered, in which case we'll be needing to replace it. Let's work that in. I can't quite get it. I'm not going to replace it because it increases the cost. So I've got that at 440 milliwatts. So deviation is 4 plus 4. Of course I couldn't test it before, and I couldn't test that before because of the modification. So deviation, for what it's worth on this test set, Wall, oh my goodness, what have they got it at? Wallow. It's showing as 25 kilohertz. So, you know, nothing like transmitting on 5 channels at once. It's not always sets with dodgy receivers that have which cause the bleed over, which have the bleed over. It's sets like this which are pumping out such a wide signal that they're generating the bleed over. Right, we'll go over to the other test set, just in case the Marconi one's lying. Let's see if I can get a figure out of this one. Wow, he's gone beyond. Maximum on this meter is 10, and it's gone beyond the 25. Right. So I want the feedback control to the centre position, which is where it is, and we just need to drop this to a sensible deviation level. Like that. That's 2.5 absolute peak. And on this test set, let's plug back in. Wallow. Oh, wrong. Wallow. 1, 2, wallow. It's showing the same, so it's working today. So, one from 25 kilohertz, I've not seen that before, to a 2.2 average to an absolute peak of 2.5. That new set we couldn't adjust, that Midland 18, was 1.8 peak, but wasn't the AGC awful on it? Automatic gain control, for those people who know what AGC is. Yeah, I'm glad it got a new improved microphone. Right, that's why it's well worth restoring really high quality sets like this, which were 100 quid at the time. Right, meter. So I didn't test any of this before because obviously the set wasn't doing any power on transmit. We are still on low power, we are. And do you know what? It's bang on the floor with no adjustment. So nobody fiddled with that. So we don't need to adjust the preset there. So I've got to rewire PA switch, and I'll do that tomorrow instead of another set. I can only put really 2 40-minute sessions per day into CB, and I often can only do that 3 days a week, so I wanted to get on with these because there's a box of 4. Right, that takes us to the receive. Now the receive was working really well, and I don't think it's been messed with. So we'll put our oscilloscope on, we'll go over to camera 3, and let's put enough volume for a sensible trace. So we're going to checking the detectors in the correct position. Slightly out, so that can affect receive sensitivity adversely. But the trouble is, you may get more sensitivity with that in the wrong position, but then you end up with the receive being garbled. So let's see what we've got now. We've got, with no further adjustment, bearing in mind it was 0.23, we've now got 0.32. So it has affected the receive adversely by correcting that. So let's see if we can get that back. So go to camera 4, shift it a bit because the mice keep moving it. Just take that down to about 6 dB. That's the meter telling me I've not switched it off. No, that was in spot on position. I've not knocked the RF gain, have I? No. I think we've got an improvement there. Now we'll put a bit more signal on to do these IFs, the intermediate frequency. Okay, so now we've got, having done that, just trim that back a fraction. That's about on the 12, isn't it? We've got 0.24 microvolts, which is about where it was before I adjusted the detector, which was out. 0.2, and for 20, 1.6. No, I'm on the wrong scale. 0.5. So you can see what's happened there. It was more sensitive than expected because the detector was out. Corrected the detector. We've got virtually the same receive sensitivity, which is superb. Back with everything spot on. So I should have done the squelch test first, but you know, let's just see where the squelch is now. It sounded noisy, that. Right, I'll put the attenuator up on the screen, and I want it to come in at 100 microvolts, but there's no hard and fast rule. I've got the squelch on full on the radio, so here we go. 3, 10, 30, 100. It comes in exactly where I want it to be. So I don't need to adjust that. Let's see where the sensitivity is. So we'll do the opposite, turn the squelch down to minimum, set threshold, switch the signal generator back on. It's parked at 0.3, and it's an excellent 0.55 microvolts. So 100 microvolts and 0.55 microvolts, so very satisfactory. Squelch preset is just there, don't need to touch it. So we haven't had to touch transmit power meter, we haven't had to touch the squelch preset. So let's see where S9 is. With 100 microvolts on the signal generator, we should have S9. And it virtually is. So it's 300 microvolts for S9. So it's a little bit lazy. So we'll just adjust there. And there we have S9. So it was 300 microvolts. It's now 100 microvolts. Meter lamp works. Switches. Yeah, well, we've got some work to do, haven't we? A lot of work. Let's check the tone works. Now I can check. I'll show you this because this affects the cyanide. I've had it on medium tone. If I change the tone, the cyanide will change. Let me put a signal on such that we have 12 dB cyanide, and then if I adjust the tone to high, it's lost its little dent. I think we're going to have to do something with that. But you see, it does change the cyanide. If we have it bassier, it's actually better. I think we're going to have that switch out at the same time as having the PA switch out. This normal clear thing's just a silly, just puts a capacitor across channel 9 for what it's worth. That's working. Let's just look at deviation. Wallow, 1212. I'll just change the clear. 1212. Let's see if I can call Mr. Chippie. See if he's listening. Tango 21 calling Mr. Chippie. Tango 21 calling Mr. Chippie. Okay, well that didn't do anything. So I'll put it on the aerial. And basically the set's done. We're doing on the air test. And then we'll just sort out that CBPA. 19, Roger. They're always off frequency because they're usually using illegal radios, aren't they? Okay, so there you are. That's hopefully got that sorted. So I won't bother doing a part 2. We'll do an on-the-air test as it is, and then that can go back to the customer. So thank you for watching, getting a York 863 back, legal and working nicely.